Hi everyone, I hope that you hear me well. Let me know in the chat if everything works as expected and the sound is there. And we should be ready to start. So yeah, I'm just waiting for your confirmation if the sound is there. And I'm ready to go. Today, I have kind of a demo session for you guys, so it should be fun. We got you loud and clear. Jason Peer, thank you very much for the confirmation. Highly appreciate that. Okay, so let me just reorganize a few windows and we should be good to go. Okay, so let me just turn on picture-in-picture mode. Don't laugh at me. Yeah, I know I have a lot of junk on my desktop. Sorry, but I'm not sorry. Okay, so say hi in the chat, please. Let me know where are you from, and we should be ready to go. Today, like I said, I have a demo session for you guys. So I created a Jupyter notebook that covers, I believe, every task supported by Florence-2, but I'm not necessarily sure, so we'll see if I'm missing something, but I don't think so. And yeah, we will have a Q&A session after I show you all of those things, but don't be afraid. Feel free to write your questions. Let me know. In between, I'll try to answer those questions during the demo session as well. Cool. I see that we have some people from Turkey. We have some people from Canada, Thailand. That's awesome. That's awesome. I hope we will have more people during today's stream. But yeah, I kind of posted very late about it on social media. The last hour before the stream is always very stressful because I need to do so many things and I forgot about most of them up until the very end. Okay, but I still hope that we will have more people here. Okay, let me just run NVIDIA SMI in the meantime, just so we know that we have access to the GPU. Hi, Lucas. Hello. Oh, hello from Los Angeles. So Jason is from Los Angeles. Early morning for you. Apologies for that, but for me it's already quite late afternoon. So it is what it is. I already ran the NVIDIA SMI in between, responding to messages on the chat. And now I'm installing a few dependencies that we'll use during today's demo. I hope that most of you already watched our Florence-2 video where we showed you how to fine-tune Florence-2 for object detection task. But today, mostly in the first part where I will be showing you the demo, we are going to talk about pre-trained Florence-2, because one of the awesome things about Florence-2 is that you can fine-tune it if you need to, but you also have tremendous capabilities in such a small model in the pre-trained version of the model. So that's pretty cool. What else do I see on the chat? We have people from Paris. Thank you very much for joining. And it's quite late in Paris, I believe same time zone as myself, so 5 p.m. India is even late, even more late. We have people from Ghana. That's awesome. Awesome. Thank you very much for joining from all of those places. It's pretty cool. And like I said, for those who didn't hear me saying that, feel free to drop your questions about Florence-2, but not necessarily only about Florence-2 in the chat. I will be answering questions not related to Florence-2 a bit later in the stream. And for now, I will focus on answering questions about Florence-2 and showing you what is possible. So I hope you'll like it. Okay, cool. Okay, so I pretty much have most of the stuff prepared. So what I did, of course, check if we have GPU, install dependencies, download few example images because I have a few images here and there that I would like to use during my demos. And now we load the model. I load the large version of the model. For those of you who don't know, there are pretty much two versions of the model. One is base, it is 270 million parameters, and there is a large version that is 770. So for the purpose of this demo, I'm using the larger one, but it's still small enough that it fits on a single T4 GPU. Let me just open the right tab for you so you will be able to see the GPU consumption. And I'm using that on a CUDA, so I'm using that on a GPU. However, I already confirmed. Some people asked me about that before. It is possible to run that on a CPU. So if you don't have GPU, that's not a problem. It's possible to run it on a CPU. There is a little bit of problem with installing this dependency, but it's possible to get around that. And it doesn't run on Max M1 chips or M2, M3, whatever. So you need to use the regular CPU if you have Max. We also have people from Thailand, from Pakistan. Super awesome to have you there. Okay, model loaded, so let's start. Okay, so like I said in the video, so those of you who watched the and Daniel Silva is asking on the chat, important question probably to ask, so let me answer that. Which model can I run with NVIDIA RTX 4070, I assume? Both of them. So if you want to run the larger one, the one that I'm running right now, notice that T4 have only 15 gigabytes of VRAM, and I'm super comfortable that it will run in this demo. So both of those should run. Like I said in the video, which I highly recommend you watch if you didn't watch it yet. It is on our YouTube channel. So we created a video about Florence-2. Highly recommend that. Florence-2 support multiple tasks. So it's awesome model because typically you have models that run only object detection or only captioning. Models like GPT-4 Vision can do like image captioning, vision question answering, stuff like that, but they don't do object detection, as we all know. So some models can run multiple tasks, but we are pretty much used to a situation that they don't. But this one runs multiple. So let's start with object detection. So I just run the cell so you can see the result for yourself. So this is one of the images that I downloaded. And we can immediately see a few things here. First of all, the consumption is around 10 gigabytes of VRAM here. And this is for the larger models, so it is what it is. But notice what we see here. Like we are typically used to pre-trained models being able to detect classes from Coco dataset. Yeah. But over here, we see a lot more than just Coco dataset. So we see stuff like wheel, for example, stuff like human face, footwear, coffee cup. Yeah, so those are clearly classes that are outside of Coco. So it's pretty cool because the pre-trained version of the model can run more than just pre-trained classes from Coco dataset. You can get more from it. Yeah, and like I said in the video, of course, if you have some classes that are falling outside of that class set, sure, you can still fine tune, and it's pretty easy. Hello from Germany, 8P. I believe that you left a comment under under the Florence-2 video, so I'm really happy that you managed to join the live stream today. Okay, so this is what we get in the first task. This is object detection task. And important thing is that Florence-2 recognize which task you would like to run from this kind of like pointing brackets format. So you include the name of the task, and we'll go through those tasks. So you will see, okay, if you would like to run captioning, I will explain what is the name of the task. This one is very weird because usually you have a full name, and here is OB instead of object detection. Is kind of like inconsistent with other things. So what we do here is we load the image. Importantly, we run that through Transformers library. So Transformers library accept images in PLO, not OpenCV. So you need to take that into consideration. I'm just passing the path to my image. So if you would be running that locally, then you just pass the path to the image, like, I don't know, for example, yeah, that would be it, yeah, for my machine. And I'm passing the text, which is kind of like the prompt, and I also will need the name of the task for the post-processing. Can I use Florence-2 with YOLO V8 in a single data set? Not really sure if I understand the question. Like, you would like to train both of them on the same data set, or you would like them in combination? That's a question coming from the chat. So I'm just responding. It takes so much space. Okay, cool. Let me just close that. So here we do a few things. If you're familiar with Transformers library, it's usually like you have model and you have processor. So processor is responsible for pre-processing your input to the model and post-processing the output from the model. And the model is obviously the part that runs the magic, yeah? So here we pre-process stuff. So we take the text and the image, and the text in our case is just OD, because for object detection task, you don't provide any additional information. And then you generate the output, generate the text, and that's it. So I kind of like explained that in the video as well. So if you would like to know the details, feel free to take a look there. But importantly, it's very unified. So the input will be always image and text. The text can be a little bit different, but the input looks like this. Then we use supervision to extract those boxes and annotations. So you probably saw that multiple times. I done that in pretty much any of my tutorials. So this is object detection. Okay, now let's move on. So we have so this is very verbose. Yeah, so I only put that once in here and decided to wrap it in a function. So later on, we will just use a little bit shorter code snippets, and I will just call run inference function instead of doing all of that, because you can see it's probably like 10 lines of code. So it will be a lot easier to follow my examples with this. Okay, so first of all, captioning. So I'm taking the same video, the same image that I took initially. So still the video image of myself and the dog in the coffee place, but this time we are calling the caption. And important thing is that Florence-2 have 3 levels of captioning, so kind of like different levels of precision that you can run. We have, and I was laughing a little bit about it during the video, there is a captioning, detailed captioning, and more detailed captioning. So very creative names. But kind of like very intuitively, they map to different levels of precision in terms of the description, image description that we get. So I first run captioning, which is the lowest level of precision, and I get a man sitting in a chair holding a dog, which is pretty accurate. Notice once again, nothing changes. We just provide image and text. That's it. So it's pretty cool. Polygemma work in the same way. Everything is unified. Everything is text plus image as input and text as output. Very handy and very easy to work with. Now we went for a more precise version of the captioning, so detailed captioning. And this time we get a bit more. In this image, I can see a person sitting on a chair and holding a dog. There is a cup and a mobile on table. There are chairs and tables. At the back, there is a building and there are trees. Yeah. So if we take a look at the image itself, that seems pretty accurate. We have a situation, myself and Leo sitting on a chair. There are chairs in the background, tables, and we have trees and building in the background. So that's still pretty accurate. So Ravi is asking in the chat, sorry for breaking the flow, can we use Florence-2 for commercial purposes? And the coolest thing about that model is that we can. It's MIT licensed model. So you can run that in enterprise projects, no problem. So that's really cool. And there's like no extra, licenses where you need to accept the terms, nothing like that. It's pure MIT license, so you can just run that in your enterprise project. And like I said, it's pretty small model. I'm running that on the smallest GPU available in Google Colab, and I still have like 5 gigabytes of VRAM to spare. Yeah, so there's that. So let's go back. So we went for detailed captioning. And now let's go for more detailed captioning. More detailed captioning is probably 2 times as long. And we see a man is sitting outside on a wicker chair, which is accurate. He's wearing a black cap, sunglasses and blue shirt. The blue shirt is probably a little bit an overstatement. I'm having like a jeans jacket, but who cares? The man is holding a brown and white dog in his lap. There is a black table in front of the man with a white coffee cup on it. Part of the building can be seen behind the man. Large green trees are standing on the side of the building. So a part of that blue shirt, everything checks out. Yes, so there is a black coffee table. There is a white coffee cup. There is once again a building and the trees in the background. We are getting a little bit of a detail about the chair that I'm sitting in and overall information what I'm doing. Abdul is saying, sir, can I use combination of Florence-2 with YOLO v9? Not really, like once again, not really sure how. But if you could give me a little bit more details on what would be the example of using them together, because YOLO v9 is a typical object detection model and Florence-2 is what you see right now. So how would you like to use those two together? Yeah, let me know in the comments and we'll try to answer that. Okay, another task is caption to phrase grounding. So let me just first run it and then we will we'll explain what do I mean. Okay, so what do I do? I'm using, so this is the first task because so far you see we provided the task and no additional information. Caption to phrase grounding is the first task that we have where we provide additional text. So we provide information about the task that we run and the text that we would like to use as an input. And now here I did very simple thing. So I was thinking, okay, can I use this task, so caption to phrase grounding, as a zero-shot detection algorithm? And I kind of can. So I was interested, okay, can I detect the tail of the dog? This is one of the tests that I did a year ago for grounding Dino. That was the model that I really fell in love with. And you can see my tutorial about grounding Dino on our YouTube channel. But back then, I used grounding Dino as a zero-shot detector. So I was just providing the name of the class that I would like to detect, and then used grounding to detect it. And you can see it detected the tail, or Leo's tail. It is detected here. But you need to be very kind of like aware of what you are doing with phrase grounding, because, for example, initially I was like dog's tail. Yeah, so I was like, maybe let's detect only, like, let's provide additional information about the dog's tail. And when I run this, let's give it a second to run, we get both. Yes, so because it's a phrase where you have dog and tail in a single kind of like description of a single object, you actually get the dog and the tail, and both of them have the same class. Yeah. So you need to be very aware of what you are doing. But for example, I can also do something like this. So I can do dog, comma, tail. And when I run this, I'll get few boxes. I'll get the tail box and 3 other boxes that I assume are boxes for dog. Let's take a look. So I'm just printing detections object and I see dog, 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 tail. So we got 4 boxes and only and 3 of them are representing actually the dog, but we see that the dog is kind of like represented in 3 boxes of different sizes and a tail. So like I said, you need to be very mindful of how you use that. Okay, let me just take a look in the chat because we got a few more messages. So let's take a look if we get anything interesting. Okay. Currently, Florence is not good with VQA. How to train it for VQA? So it is not. It's very weird because apparently Florence-2 does not, I mean, not apparently. Florence-2 does not support VQA out of the box, strangely. There's a really cool blog post by Andres, Merv, and myself on Hugging Face, where we show how to train Florence-2 for new tasks. So another awesome thing about this model is that you're not bound to the tasks that I will show you today. Those are the tasks that you get out of the box from the model, but you can expand and add new tasks. And this tutorial shows you how to add VQA for documents. So, you know, questions like who is the author of this paper? I mean, whatever is there, questions about the diagrams. Yeah. So for example, how many tokens per image does it use? And there is like some diagram describing some VLM or LLM, and you get the answer based on that. So that task was not there out of the box, but still Florence-2 is flexible enough that it allows you to add new tasks. So if you would like to have a YouTube video tutorial about that, and I'm speaking to Ravi right now, but probably other people as well, showing you how you can add VQA or document VQA. All of that is possible, and you could do it. If you really need that answer for now, I recommend reading that blog for fine-tuning Florence-2 Microsoft Cutting Edge Vision Language Model. It is on Hugging Face. And yeah, I had an opportunity to work with Hugging Face people for that, so that's pretty cool. Let me go once again to the chat. I'm sorry, I'm jumping between the collab and the chat, but I would like to answer your questions if possible. Interesting. There is 3 different coffee labels, although it's only mentioned coffee. I wonder how it works. The white pixels are coffee, and the white cap is coffee is cap itself. Yeah, I mean, I recommend using that kind of like in a very aware manner. So similar how we done that with grounding Dino in the past. So you need to filter out those outputs and only look for things. Either ask specific questions about the image so that you get precisely the output you want, or ask general questions but then filter out the output so that we get something that is more meaningful, because that is quite a lot of information. Yeah, so it would be pretty hard to get meaningful information just from the output, raw output. Yeah, so we need a little bit more of post-processing. That's very nice with the precision on the dog with the tail. Yeah, I really like that. Yeah, and it's also like very specific question. So if the model really can detect the tail, which is like super small within the image, that's pretty cool. Ravi wants a VQA tutorial on our YouTube channel. I will speak with my manager and we'll see how it goes. I already work on another tutorial about football related tutorial because we have Euro still, so I wanted to do something really cool about the sports, but maybe we'll go back to Florence-2 once I'm done. Any idea how to approach video task? Yeah. Georgi Bryant is asking about video tasks. Yeah, I have ideas how to do that, but I will show that a little bit later in the stream. So stay tuned. I also managed to use Florence-2 to do video processing. What else do we have here? Can we custom train Florence-2 for object not in Coco datasets? Absolutely. So Hema probably didn't watch our tutorial on YouTube, but you can fine-tune for objects outside of Coco datasets. Just watch my tutorial, Florence-2 fine-tune Microsoft multimodal model, or it's the latest video on our YouTube channel. And here I showed how to fine-tune for object detection on the custom dataset. Okay, we have a lot more questions on the chat, so let me just move on in the meantime, okay? And I will go back to your questions because I really would like to show you a lot more cool things. Okay, so I also mentioned that in the video, but one of the awesome things about Florence-2 is that you can combo vision tasks. So the most straightforward and kind of like obvious combo that you can do is captioning plus phrase grounding. Yeah, so a situation where you first get the description of the image and then you use that description to get phrases. And the interesting thing is that if you run that on the same image, so this is the output we got from object detection, so pre-trained object detection, this is the output, yeah? And now the interesting thing is that if we run captioning plus grounding combo, we will get different bounding boxes. So it's interesting that you can get kind of like, I'm not sure, like more information about the image, but also seems cleaner, although somebody also pointed it out that we got multiple boxes for table in the first query, and we have the same situation right now. So we have the person, we have the dog, we have the chair, chairs, probably some buildings. Let me just print out detections so we'll get more information. We have person, chair, dog, cap, table, chairs, tables, building, trees. Okay, so a lot of like repetitive classes over there. But it was also like very messy scene. So there is a lot of stuff happening here. And the model is detecting that. So like I said, captioning plus phrase grounding combo, that's pretty cool. And like I also showed you, you can use that phrase grounding in different ways to get maybe classes that you are precisely interested in. Another one that we could try, maybe it's finger. So finger, I'm just pointing that finger to Leo, and you can see we can get that finger over here. So that's pretty cool. Let's move on. The next one is open vocabulary detection. So that's pretty similar to phrase grounding if you use it in the same way like I did. So I use phrase grounding in the beginning to show you that you can do zero-shot detection with your classes. And you can do it also over here. I just showed you that example with finger, and here I'm using open vocabulary detection to get that finger as well, and it's getting detected. I also had another, that's also another pretty cool image to try on. So here there is a straw over here, and I remember testing grounding dyno to detect that straw. So let's take a look if Florence will be able to detect that straw. So here is the straw. Also think about it. It's a very long, thin object, but you can still detect that with Florence-2. All you need to do is provide the name of the task and the name of the class. The downside is that when you run phrase grounding, you can provide multiple classes if you want. You can get weird results, but you can still do that. When you do open vocabulary detection, you cannot provide multiple classes. So if I would try to do like straw, comma, dog, for example, yeah, and try to run this, it will try to come up with the bounding box that combine both straw and the dog in it. Yeah, so that's kind of like suboptimal. You cannot have multiple classes over here. So you need to have only one class for open vocabulary detection with Florence-2. Okay, let me just take a look if we have more questions in the chat. Can you do a video, something, or talk about how can I integrate Florence-2 with NVIDIA NIM environment? I'm not sure because I'm not very familiar with NVIDIA NIM environment, but you can give me a little bit more details and maybe we'll try to figure it out. Can Florence be used to describe what's in the medical images? So I don't think out of the box. Most of the foundational models don't have a lot of knowledge about like medical images out of the box, but I'm pretty sure we could fine tune it. So if you have a data set that you could fine tune that on, then I'm pretty sure you would be able to get, captioning, image captioning for medical images. That seems very doable. If we could do VQA for documents, I'm pretty sure we could do image captioning for medical images. When we fine tune Florence, is there any value in duplicating label data with different wording for the same information? I think there is. We did that for Polygemma. So for Polygemma, we kind of like artificially expanded the data set by doing different permutations of bounding boxes. So pass the bounding boxes in different order. That all works. All of the typical augmentation techniques that you do for object detection, where you flip images and apply different like transformations on the images, all of that can impact the quality of the results. So that was also something that I probably should have mentioned in my YouTube video. At the very end of the video, I showed you the result for fine-tuning Florence-2, and it was MAP at around 0.75, and then I showed you, hey, it's fine-tuning for YOLO V8, and it was 0.90. But think about it. When you fine-tune YOLO V8, you apply a lot of augmentations to the dataset. Even if you don't do it manually, YOLO V8 apply a lot of augmentations for you. Florence-2 was trained on a raw dataset without any augmentation, and we still got like 10% MAP close to YOLO V8. So I actually am tempted to like try hard and think about add augmentations, add better post-processing, train a little bit longer to see whether or not we would be able to get even closer to YOLO V8. But I'm pretty confident we could do that. So augmentations definitely help. I'm also curious how Florence-2 would work with something like gaming content. So a screenshot from video game, you mean? Because I'm not sure. Okay, I'm waiting for the answers on the chat, and I will move on to the next task. This is something interesting. So previously I showed you zero-shot detection, yeah, and I show you object detection. But when you do object detection, you get boxes with one name, one word descriptions, kind of like classes for those boxes. Yeah, but there is also a task in Florence-2. Sorry for scrolling so much, and that task is called dense region captioning. So this is pretty cool because you get the bounding boxes plus descriptions for those bounding boxes. Yeah, so here we run the same image that I ran before. So the one with Leo sitting on my lap in the coffee place. And now we get bounding boxes. Interestingly, we get different bounding boxes, but we also get description. Somebody asked me if Polygemma recognizes colors. So here's an interesting thing. You have blue sneaker, which tells me that it can recognize the color. We have black and white high top sneaker, yeah, and so on, yeah. So there are colors in those descriptions, and those colors are accurate. So it seems like Florence can recognize the color. Although, if we would use blue sneaker as the name for open vocabulary detection, so let's go a little bit back. Maybe here. Let's do blue sneaker. Sorry, sneaker, yeah. And run that. And interestingly, when we do open vocabulary detection and I ask about blue sneaker, I get both of them. So it kind of recognizes color, but only in specific scenarios. So if I ask about that in open vocabulary, caption to phrase grounding, it gets two of them. Let's go to open vocabulary detection and try this. It was just a different image. So let me just adjust those parameters and run that. Here in open vocabulary detection, we get only the blue one, which is very interesting. This is very interesting because I so far didn't really saw differences between open vocabulary detection and phrase grounding when I use that in this like zero-shot detection manner. But here we see that it recognized the blue one. What was the name of the class here? Black and white. Okay, so let's go black and white. Let's go black and white. So it's a black and white sneaker. And we got that this time, which is also correct. So, of course, it's a very small sample of tests, but it seems that it can recognize colors. So, Tilak, Tilak David, I hope that I pronounced that correctly. It looks like it recognized colors. Okay, so let's go back to the chat. Can we detect a particular text word in the phrase using Florence-2? I will show you that in a second. We will go into OCR, and I swear this model blew my mind when I think about how small it is compared to like all of those big VLMs and how good it is on OCR. So I will show you the OCR. So Qatar, wait a second, we will show you. How do we train Florence-2 on image segmentation? This is one of the things that I would like to do. So I will show you, maybe I will write a blog post about it. I'm not sure if we'll do a video about it, but you can certainly fine tune it for segmentation on custom dataset. Object tracking, Mohammed is asking about object tracking. I don't think so. Object tracking is something that you would need to build on top of that, but that's really simple to do if you do use supervision. Okay, let's go back. So what do we have here? Okay, we ended up at dense region captioning. So this is what we get. So we get a longer descriptions if possible for different bounding boxes. Now let's talk about the region proposal. Region proposal is a task where the model, let me just drink a little bit of water. So region proposal is a task where model looks for interesting regions on the image. I'm not really sure what criteria are used here, but in the end we get a set of bounding boxes, and only that. Yeah, so we get those numbers because we added those numbers within supervision framework, but those are not there. We only get the bounding boxes. And of course, like you can think about it, you could potentially use those bounding boxes as an input for a classifier, for example. Yeah, so a model that can you just crop that bounding box. Yeah, you get that small patch of the image, and you run that through the classifier. Maybe get a little bit more information about that specific patch. But yeah, that's what you get. So you get a set of bounding boxes that you can later on use on the next level. So multi-level, multi-model setup. Okay, now we are going to talk about OCR. So Florence-2 have two modes for OCR. There is a general OCR where you just run OCR on the whole image. You get text, as a single string with all the text that was in the image. So that's one of the modes that you can do. But there is also a second mode where you get bounding boxes plus the text within those bounding boxes. And that's really cool. We also get a question on the chat. Can we run Florence model on folder of images. I mean, you can do that. You just need to loop over the folder. So out of the box, no, but you can just list all the images in the folder and run one by one. So I don't see any problem with that. How can we combine RAG with this? Florence-2 for VQA. Let me think about that, and I will answer. Maybe we'll come back to that question at the very end. But I think that we could. Okay, so let's go back to OCR. So here I have an image of the car, and you already see the output. So there is like no fun in that. But I was curious, like, could we detect a text that was on a license plate? And yeah, we absolutely can read the license plates of the car. It's probably kind of depending on the size of the text. That text is a lot larger than, for example, this one. But I think that if you would crop that region here, you would probably be able to run that OCR. But this is one thing, okay? So being able to read license plates, pretty cool. But you know, there are probably more complicated things than this. So I have this image. Take a look here. This is a handwritten like scan of a handwritten note. Attachment to claim for Gotriel question for. You know, you can kind of read that, but it's hard even for a person to read that. Yeah, and we are used to the fact that, I don't know, like GPT-4 Vision can read things like this. So can read text that is handwritten and in poor quality. But I'd say like traditional OCR, like Tesseract or something like solutions that people use for OCR, I'm pretty sure they would have a lot of problem with reading something like that. So let me show you what we can get with Florence-2. So I'm running OCR with region. Let me just press enter and give it a little bit of time. And here's what we got. Yeah, so that could be a little bit easier to read if we would have different text color. Let me just adjust the text color. Okay, so we will just use black color to annotate that. Let it run once again. OCR is a little bit slower, as you can see, taking a little bit more time. But yeah, in the end, we got it. So we see question 4, correlate called ICE, Office, Camelon. And held on to my papers, and I was not free to leave office. Cameron gave up. Tag my papers away after ICE arrested me. This is violation. Yeah, so it's pretty cool because, to be honest, I would have hard time to read that. So if you can imagine that if that can read the handwritten text like this, it should be pretty easy to read text that was, I don't know, printed on a piece of paper. And I also would like to show you the second mode where instead of getting those bounding boxes plus information, we get just the whole text. Attachment to claim for Gartiel question 4, court called IC on my papers, and I was not free to leave. Officer Colin gave up. Tag my papers away after IC arrested me. You see, so there is a high chance that, you know, it makes some mistakes, but in a text like this, I think it's pretty acceptable. And if we could run that on something that's a bit easier, then I think that it would a good job. Okay, let me just go in the comments. What about 3D image segmentation? No, 3D image segmentation is probably not there yet if we talk about a model like this, but maybe at some point. Is Florence-2 can identify structure of the document and recreate it. Not out of the box, but I'm pretty sure if you have a data set that we could use to train that, I'm pretty sure it could. I'm pretty sure it could get the structure of the document. We just need to have a fine-tuning, do the fine-tuning for that specific task. How does Florence-2 compare with Polygemma for image segmentation for recognizing a single object in a cluster? I think that both models have pretty similar capabilities, but Florence-2 is easier to fine-tune than Polygemma from what I saw. It's easier to get a high accuracy. Unlike most models, why Florence is not giving a confidence score while inference. So why you don't get a confidence score? I can show you why. Because it's a model that is based purely on text. So if you have YOLO v whatever, yeah, you get those confidence levels. But actually the response that is coming from the model, and I was talking about it in my video, so you can take a look there. So I'm running this object detection on the image. Here is how the response from the model looked like. So it's a text. It's literally a text. So there is no confidence associated with the bounding boxes. You can have kind of like the gist of it, like the sooner that comes within that sequence, it's probably more probable and have higher confidence level. But there is like no confidence associated with that, and it's kind of like related to how LLMs works. Yeah. So if you use YOLO v8, you are used to the fact that you get the metrics of numbers and they have confidences. Here, there is like no metrics of numbers. We parse that to get the metrics of numbers, but literally you get the text. And that's why there is like no confidence associated with those detections. Okay, do we have any more questions? How do you think Florence-2 would work with video game content, especially with the VQA side? So I think that if you want to do any VQA, you need to do fine tuning. And to be totally honest, I saw some people trying screenshots from video games with Florence-2 and didn't get the best results. So I think that absolutely, if we would do like serious fine-tuning, then I think that it's possible to get good result, Jason, but not out of the box, I'm afraid. Okay, now fun stuff, segmentation. So you can do referencing expression segmentation. This means that you can ask questions about the image and get mask associated with that phrase. Not necessarily questions, sorry. You can pass a phrase, yeah, and an image and get something like this. So here I use like pretty basic question man. And to be honest, that's one of the tasks that works probably the least good. So here's we have man, okay, that was pretty easy, yeah. If we would go for a dog, it probably would work just as well. If we will allow it to run for a little bit of time, so please be patient in the meantime. Yeah, this one is taking a lot of time. So segmentation and OCR with boxes tend to take much longer. And you see, we got like malfunctioned mask. And I'm not sure if that's because we do poor job at post-processing, or do we just get the poor result from Florence-2 model? So yeah, segmentation is kind of like, you know, up in the air. I think that it's still have a lot of work to do. But now there is another pretty cool stuff. So Florence-2 allow you to do something that you probably did with segment anything model. So it allows you to define to prompt the model with the bounding box. So let's say that we define a box with Leo in it. Yeah, I use one of the Python packages that allow you to draw those bounding boxes within Google Colab, and that gives you the coordinates of the bounding box. Sorry, I just need to constantly swap between the zooms. And now I explained that in my YouTube video. You need to do a little bit of post-processing. So we cannot operate on coordinates going straight from the image. We need to do post-processing. So I showed you that we have a coordinates of the bounding box. We put them in the order x1, y1, x2, y2. Then we divide them by width and height respectively, which means that we pretty much normalize the coordinates of the bounding box that we are interested in. And then we multiply that by 1000. So essentially at the very end, our coordinates of our bounding box that is a query should have values between 0 and 999. And that's it. And then you convert that into this representation. Like if you want to learn more, yeah, we've done that in our YouTube video. So I highly encourage you to do that. So what I'm doing here is exactly this. I'm taking the bounding box, putting that in the x1, y1, x2, y2 order, and I normalize that and I multiply it by 1000. So there's that. In the end, we get something like that. So this is our representation. This is our representation of the region that we are interested in. And then we can use that as our prompt. So we can query Florence-2 using this representation in our image. So let's take a look how we do that. We have another task called region to category. So this task gives you information about kind of like a classification for our region. Yeah, probably we could use region proposals as a combo with that. So we could do region proposals, use those bounding boxes as an input to prompt the model. Yeah, so let's do this right now. So region, we have region to category. We defined our region, so there it is. We have our image. Let's run it. So now we should be able to get response, and the response is dog. Yeah, so we do kind of like the reverse of what we did first with zero-shot detection. Yeah, so we did like, hey, what is this? And we get information, this is the dog, yeah? And previously we said, where is the dog? And we got the bounding box. So those are kind of like those operations that you can do kind of like in two directions, yeah? Hello from Kurdistan, hello. Thread, hello. I hope that I read your image correctly. So this is this. So this is a kind of like a classification based on the bounding box. But we can also get a region to description where we give the bounding box, and I use the same bounding box for now, and we get a little bit more information. So we get man holding beagle puppy. Yeah, there's that. Yeah. So now, I don't know, let's go back to the prompting and say, hey, what is this, for example? Yeah. And when we run cells below, we should get information that this is a footwear. Okay, and this is a sneaker, yeah? So kind of like a high level information. This is a footwear and a sneaker. What else could we do? Maybe we could load a different image. Let me just take a look. Maybe we'll get a little bit more. Okay. Yeah, let's run this. Yeah, what are those things? And we could parse our region and then get a category. The category is tableware, which is correct. And here we will get a little bit more cocktails, okay? So there you have it. So you get two tasks that you can use the bounding box to query the model, yeah? So there's that. Okay, so those are all the examples that I prepared for you. By the way, we have two blog posts that I highly encourage you to read. The first one is kind of like the rundown of Florence-2 and what you can do and how it was trained and what is possible, etc. And the second one shows how to fine-tune the model on custom data sets. So many of you asked, like, how do I do that? So here, there's a whole description on how to do it. And it's also pretty cool because right now, if I go to Roboflow, and I hope that you use Roboflow to manage your data sets. If I go to Roboflow and I go, oh, it's like new UI. I didn't expect that. Okay, but regardless, and I go to my data set, you can right now download the dataset in the format that is compatible with Florence-2. So if you would like to fine-tune Florence-2 on your own object detection dataset, you can do it, and this is how you can export that. Okay, so at the very beginning of the video, somebody asked like, can I run Florence-2 on videos? So yes, you can, and I kind of like done that. It's still far away from the result that I would like to get, but there is a Florence-2 video space on Hugging Face that I created. And what you can do is you can pretty much upload your video and get detections for that video, and everything runs as a zero-shot model for with Florence-2. Unfortunately, like because I'm running that on Spaces, there is like limited amount of time that I have to finish my processing. So I limited the processing to only 2 seconds of the video. But if you would fork that and run that locally, then you could actually do a lot more and process longer periods of videos. And how that works is I'm also doing the combination of 2 tasks. So I'm doing captioning plus caption to phrase grounding to get those detections. I will probably work a bit more on that, but I just wanted to show you that all of that is possible and you can do it if you want to. Okay, that's all from me. So if you have any questions, feel free to drop them on the chat, and if no, then I'll probably wrap it up. So that's the last moment to ask questions related to Florence-2. And if not, then remember, you can always catch me on Twitter or LinkedIn or other places. So I should be there as well. Okay. I don't see any questions on the chat, at least for now. So if that's the case, okay. Can you do a video for tracking with Florence-2, Mohammed? Because I'm not really sure if about the tracking. Oh, I see questions start to appear now. Okay, that's probably the lag between the chat and myself. Okay, so if we talk about tracking itself, I have plenty of videos about tracking. If you would like to use Florence with tracking, not sure if I can show you how. Because I already done that. That space shows you how to do it. So if you go to Files, that space is actually what you need if you would like to do tracking with Florence-2. Here is the tracker, and I actually create. You see, I do the caption, then I do the detections from caption. I have the detections, and then I do tracking. So if you would like to do Florence-2 with tracking, I highly encourage you to take a look at the space. Because it pretty much shows what you want. It shows you how to do object tracking with ByteTrack and Florence-2. But like I said, feel free to ask questions. You can do that in the comment under this live stream. I will still respond to those comments even after the stream. You will not be able to do it in the chat, but in the comments section. What else? For fine-tuning, oh, we lost the connection for a second. Whew. I hope you guys still hear me. Okay, so for the fine-tuning, what I was saying. Okay, I remember. So if you would go to the notebook where I show you how to fine-tune, you see, we really need to end the stream because technical stuff starts to break, but I'm still around. So take a look here. I have this collab for fine-tuning, and I run a base model, so the smaller one with 270 million parameters. I use LoRa, which is a way to optimize the amount of parameters that you train. And I kind of like explain a little bit of that in my video. So I have this, and I still needed to have 20 gigabytes of memory to train. Yeah, and that was base model. Large model is 3 times as large. So you would need probably like 60 gigabytes to train it. Of course, like if you are really persistent, you could probably just update this. Let me just update the batch size. Yeah, and run, where do I have the batch size parameter? Yeah, so probably if you would run this as 2, you would be able to do the fine tuning of the large model, but that's just my guess. Yeah, so it will be pretty hard to fine tune the large model on free Google Colab. That's what I'm saying. Any specific places where you would still choose grounding Dino over Florence-2? I was thinking about it for quite a lot of time, Jason, and to be honest, I start to develop a feeling that no, that I would prefer Florence-2 over grounding Dino. I think there was like not a single. I would need to measure that somehow, yeah, on a larger sample of examples or whatever. But I think grounding Dino is a very similar capability of Florence-2. Florence-2 might be better, but Florence-2 is definitely faster. So grounding Dino takes like 1.5 seconds to process a single image. And here you definitely, one thing for sure, Florence-2 have definitely more favorable trade-off between speed and accuracy. So if you care about kind of like the combination of accuracy of zero-shot detection and the speed, Florence-2 is definitely better than grounding Dino. As for overall accuracy, I still think, in my opinion, at least today, on the 3rd of July, I think I would choose Florence-2. So that's the answer to Jason. A detailed region caption. If I want to fine-tune a model with my custom data, what kind of base model would you recommend? I was fine-tuning the smaller model and I was really happy with the result. So I was fine-tuning literally less powerful model and got really good results for object detection on custom dataset. And I think that I have no reason to tell you that larger would do better. So I think that I would definitely start with the smaller one, especially like I said, it's very hard to train the larger one for free because you need like 60 gigabytes of VRAM. So you should be fine with the smaller one. Okay. I don't see any more questions. And in that case, quite possible that I will finish the stream. Thanks for the session. Yeah, thank you very much. Thank you very much for the session. It was a little bit different session than usually because usually it's like straight up VQA, and today we did a little bit of like hands-on experience, at least in Google Colab. So there's that. Yeah, if you didn't watch the video about Florence-2, make sure to watch it. If you would like to run my code that I ran today, make sure to check out our Roboflow notebooks repo. The second one from the top is how to use pre-trained model with all of those VQA tasks. So the collab that I showed you guys today. So make sure to take a look. Yeah, and that's all. I plan to create a lot more content about Florence-2. So I will, like I say, I'm building my space for video processing and tracking with Florence-2. So if you are curious about that, take a look at my space, Florence-2 video on Hugging Face. And yeah, that's a wrap. I hope that you will follow our content about Florence-2 and not necessarily about Florence-2 in the future. Thank you very much for joining, because it's an awesome thing to have you all over here and have people actively typing on the chat. That's very important for me, because I am always scared that I will be the only one over here and I will be talking to myself, and I really wouldn't like that to happen. So thank you all for joining. Yeah, have a nice evening, afternoon, morning, wherever you are, and see you next time. Thank you very much. Bye.